This is solving systems by elimination. So my system of equations is 3x equals 7 minus 2y and 8x plus 7y equals 12. So to solve by elimination, we first have to get the two equations into standard form, which is ax plus by equals c. Luckily, the second equation is already in standard form. So first, to get the first equation into standard form, we just move this 2y over to the side of 3x, and we end up getting 3x plus 2y equals 7. So to eliminate, and this is eliminating x to solve for y, we have to multiply both sides by the coefficient of the other side of the other equation's x. So here we multiply this equation by 8, and the second equation gets multiplied by -3. So we end up getting 24x plus 16y equals 56 plus negative 24x minus 21y equals -36, and this ends up being y equals -4. So to solve for x, we just plug in our y value into this equation right here. So we get 3x equals 7 minus 2 times -4, and we end up getting x equals 5. So our result for our solution is x equals 5 and y equals -4. So to solve for x by eliminating y, we basically have to do the same thing as solving for y by eliminating x, but this time we have to get the y's in the same value. These are already put into standard form, these two equations. So to get y in the same value, we have to multiply the y's by each other's coefficient. So here we have times 7 for the first equation and times -2 for the second equation, so that they can cancel each other out. So here we have 21x plus 14y equals 49, and here we have -16x minus 14y equals -24. 5 to get x on its own, which is 5. Then we take the first equation right here, and we have to plug in our x value, which we have just gotten. And so we have 15 plus 2y equals 7, and then we get y equals -4 as our answer, and here we see that the solution is, again, x equals 5 and y equals -4. Solve systems using substitution. So my system of equations here is still 3x equals 7 minus 2y and 8x plus 7y equals 12. So right here, first, to solve equation 1 for x and then substitute it into equation 2 to solve for y, first you have to calculate x, right? So this is the same equation as here. We divide by 3 to get x totally on its own. So we know that x equals 7 over 3 minus 2 over 3y. And then we can plug this into the second equation and solve that. And at the end we get y equals -4. So since we now know y, we can get this equation that we just made for x and use it to figure out what x is. So we plug in our y value right here. This should be a y. Looks like an x. But so which is -4. So we use that to figure out that x equals 5. So our solution is x equals 5 and y equals -4. Another way to use substitution is to solve equation 2 for x, and then substitute that into equation 1 to solve for y, and then calculate x. So here we are solving for x, and this is equation 2. We do this by first isolating x, and then dividing by 8 to get it totally on its own. And we get x equals -7 over 8y plus 3 over 2. So we plug this in right here, what we just got for x, and we have this equation right here. So we solve it, and we get y equals -4. Right here, we take what we had over here, and we plug in our y value that we just found. So we have x equals -7 over 8 times -4 plus 3 over 2, and we solve that for x, and we get x equals 5, and our answer is x equals 5 and y equals -4. So I also solved my system of equations by graphing. To do this, you have to put your equations into slope-intercept form, which is y equals mx plus b. So I did this by first isolating the variable, and in this case you have to isolate y. You can do this by moving over any numbers, or and then you divide by the coefficient of y to get y alone, and in this case I got y equals 3 over 2x plus 3 1/2, and y equals negative 8 over 7x plus 1 5/7. So to graph this line, I had to make a few tables. So here, to make this table, it was pretty easy because all I had to really do is get the y-intercept, because I know that the y-intercept means that x is 0, and I know from here that y is 3.5, and I could just add to go up. I could just add by 1.5, and to go down I could subtract by 1.5 since my slope is negative 3 over 2, which is negative 1.5. But for my second equation it was a little harder, since these are a little harder numbers to work with. So here I decided to substitute my x values into this equation to find some y values, and I did this just by replacing x by whatever x value I had decided on. So you can see here I just added these and got y equals 2 6/7 when x is negative 1. So I plotted all these points from my table, and I found that the solution was 5 and negative 4, which